This chapter is going to focus on weather, and we're going to be pulling together all of our knowledge from the last three chapters, the two on atmosphere and the one on precipitation and moisture and clouds. And we're going to talk about weather, how we have huge air masses that are moving around, causing different forms of weather. And we're going to talk about three forms of severe weather: thunderstorms, tornadoes, and hurricanes. Weather is caused by air masses interacting and moving across large continents. And an air mass is just a really, really large body of air. Usually they can be up to the size of a continent. Usually these are going to be about 1,000 miles or so in diameter, and they're also going to be several miles thick. But one of the cool things about air masses is that it doesn't matter the altitude of an air mass or how high you are above the ground. Within an air mass, the temperature and the humidity, the amount of moisture, remains the same at any altitude throughout that air mass. But when we have these air masses that are moving around and interacting with other ones, it's going to cause weather. This map is just showing us an air mass. Seeing where it starts in northern Canada, you can see that this is almost the size of the entire country. But because it's starting in northern Canada, in a high latitude where it's very cold, this is going to be a very cold, dry air mass. And it's at negative 46 degrees Celsius. But this air mass is going to start moving south across America and then into Mexico. And you'll notice that as it's moving south, this cold air mass is starting to warm up. By the time it reaches Mexico, it's gone from negative 46 degrees in temperature all the way up to a positive 10 degrees. But as this air mass is moving across North America, it's going to be causing different forms of weather as well. When we're talking about air masses, we care a lot about its source region, or where exactly this air mass came from. Because knowing the source region, it's going to tell us two important properties of that air mass. And that's going to be the temperature and the amount of moisture within that air mass. We'll be able to identify the temperature of the air mass based on the latitude in which it originated. So if we have an air mass that's originating in a polar or an Arctic area, these really high latitudes where it's really cold, that air mass is going to be really cold. On the other hand, we can have tropical air masses that are starting off in our low latitudes in our tropical environments, and this is going to create a very warm air mass. But the second thing that we care about, other than temperature, is the humidity. How much water is this air mass carrying? And here we're going to have two different types, our continental and our maritime. Our continental air masses originated over a continent. Because they're forming over land, they're going to be fairly dry air masses. But our second time is called maritime, which is just another word for ocean. And because these maritime air masses are forming over our watery oceans, they're going to be very humid. They're going to be holding a whole lot more water than our continental air masses do. So combining the temperature and the water content together, we're basically going to have 5 types of air masses on our planet. The first one is going to be our continental polar, which you'll find here in central Canada. Here, because it's continental, it's going to be dry, and because it's polar, it's going to be cold. Our second air mass is our continental Arctic. Again, continental, it's going to be dry, but with Arctic, it's coming from the Arctic, our North Pole. It's going to be even colder than that continental polar. But then we're also going to have our continental tropical down here in like Arizona. It's still continental. It's going to be very dry air, but because it's tropical, it's going to be very hot. We're also going to have our maritime polar. Maritime meaning ocean, so it's going to hold a lot of water vapor, but polar is going to be cold. And then finally, we have our maritime tropical. It's going to be very humid. It's holding a lot of water vapor because it's forming over those oceans. But because it's forming in a tropical area, it's going to be a very warm air mass. Even though there are 5 basic types of air masses, we're going to see that 2 air masses affect North America the most. And these are going to be the continental polar and the maritime tropical air masses. So if we're looking at North America, at least east of the Rocky Mountains where we live, we're going to see that the continental polar is going to be one of the most important ones. This one forms in northern Canada. It's continental, so it's going to be very dry air, and it's polar, so it's also going to be cold air. But with this continental polar, it's going to be very different depending on which season it is. In the winter, it's going to be bringing cold, dry air from Canada to America. It's going to cause a lot of winter storms. But in the summer, it's bringing down cooler air and helping relieve some of the heat in the Midwest. The second major important air mass in North America is the maritime tropical. And for us here in Florida, this one is probably more important. This is going to affect all of the Gulf of Mexico and most of the Atlantic Ocean. With this maritime tropical, maritime means that it's going to be very humid. It has a lot of moisture in that air. Tropical tells us it's going to be very warm. So this maritime tropical brings warm, moist, and unstable air in from the oceans over land. And with it, it brings a lot of precipitation. The other 2 kind of important air masses we have here in North America are our continental tropical and our maritime polar. The continental tropical is where we will see it affecting the Southwest and parts of Mexico. With this, because it's continental tropical, it's going to be dry but hot air, which is part of the reasons why we have a desert. And then the final one is our maritime polar. This is bringing cold, humid air that's bringing a lot of precipitation in. And this can cause what are called nor'easterners. These are huge storms in the Northeast where we just have absolute dumps of snow, where we might be talking about 5 or 10 feet of snow in a single storm.